Cosmology. Time is force. Four-dimensional dynamics field. Cosmology. Theoretical physics. Cosmology. Time is force. Started writing in 2008. Light velocity, gravity, mass, electromagnetic force, nuclear force. Time is generated from the dynamics of the expanding universe. This expanding space is a four-dimensional space. It was an intellectual adventure that I began by groping, but I think that I was able to explain a very simple and unified principle of the universe, the theory of all things, or the grand unified field theory. The theory of all things is a theory that uniformly describes four forces existing in nature, namely, electromagnetic force, weak force, strong force, and gravity. I thought that the theory of all things could be made by estimating only one force, not by the existence of various forces. Theoretical physics is a field of physics that constructs a theory based on theoretical models and theoretical assumptions, explains known experimental facts and natural phenomena, and predicts unknown phenomena. Light velocity, gravity, mass. Time is generated from expansion of space. Cosmology. Time is force is a four-dimensional dynamics quantum field cosmology that provides insight into the causes of light, speed, gravity, mass, and time. Explains the principle of space in which the universe is observed as an infinitely expanding universe to individual observers. In fact, neither gravity nor time can be explained by current physics. I thought that if I thought freely in this unknown territory, something else would be visible. We started by thinking that time is not our concept but a system that works like waves and moves elementary particles. Image of gravity and time. When we shoot with a camera, fast-moving objects should be set to a fast shutter speed. Still, the subject expresses time as blur. Even if it is a still image, the flow of time is recorded in it. Without the thickness of time, events cannot be confirmed. We imagine a landscape where all movement stops when time stops. However, without the energy of time, the movement of the atom stops and the space itself disappears. Light will not be light and matter will not be able to maintain its form. When scientists think about the problems of gravity and time, I want to explain from a macrocosmic image to a micro-elementary particle world with one theory. However, these things that make up time and gravity are not necessarily things that have a size. First thing I wondered, wouldn't it be unnatural for the light from the light source to suddenly reach the speed of light? It would be possible if the space had a built-in photon transport system. If the space is expanding, do the gravity and the time decrease in density? Is the decrease in time energy balanced by the decrease in time operating speed? It is said that nature prefers symmetry. Therefore, anti-gravity against gravity, antimatter against matter, anti-universe against the universe is imagined. In the laboratory, there is something that can be reproduced, but its existence in the real world has not been confirmed. The symmetry that I thought is not anti-specific, but something that seems to be heterogeneous such as gravity and time is actually creating the spread of space-time in cooperation. The way energy works is like a belt conveyor carrying elementary particles moving at the speed of light. The photons riding on the belt conveyor are not accelerated but light speed at that moment. Assuming that time is a system that works like a wave and moves elementary particles, light and particles will travel through space on this time wave. Since all particles are affected by time, there are no lights or particles that are stopped. The energy of time creates a separation between particles and is a force that supports its existence as a substance. Given that gravity acts in the direction of contracting space and time acts in the direction of diffusion, are the two forces fundamentally the same? Wave universe model. Suppose one of the concentric waves created when you throw a pebble into the water is our universe. The waves look like they are moving, but they don't move, they just vibrate up and down. Is the same thing happening in space? In other words, the universe expands because the energy of the waves propagates around. Does it mean that the outer space is filled with unknown materials that make up the universe? The density of the universe is not very high, so it is no wonder that it is filled with unknown materials. There is likely to be an unknown space surrounding the universe. The wave expands while maintaining the initial energy, so the energy density decreases. This observation universe spreads like a wave in a space without a center, so it has conditions as an expanding universe model. Space range that we can observe. The real universe today is an independent universe that has lost its relevance to the Big Bang, but what we can see is the information of light arriving along the water drop-shaped surface, continuous time surface. This has been observed as a multi-exposed photograph from the past to the present. Even in the Big Bang cosmology, there is a logical contradiction if the space before the Big Bang is not assumed. It also defines the energy of the initial explosion as expanding the universe to date, but recent observations have confirmed further accelerated expansion. And the mechanism that creates this accelerated expansion is currently unknown. Creating a cosmic map, the universe spreading like waves. This cosmological map is drawn as a two-dimensional model, but as a rotating body on the vertical axis, it can be seen as a three-dimensional and time four-dimensional expanding universe model. Cosmic diagram animation description. A bird's-eye view of the entire universe, showing 13.8 billion years of expansion in the path of light reaching Earth. Light arrives on the Earth along a drop-shaped surface, continuous time surface. The inside of the water drop shape is the part of the light route in the past. The expansion of the universe that started in the universe is represented as S1 to S7. Assuming that the interval between concentric circles is 2 billion years, the current universe is the seventh one, so it will be 14 billion years. The reaching limit of light shown in the figure is the range of this outer space. Outside the reach of light is the area of the container of the universe, not our space-time. How the universe looks. Light traveling from the P2 point to the Earth in the S4 era can be observed on the Earth today, 6 billion years later. Light traveling from the point P1 in the S3 era to the Earth passed through the Earth billions of years ago and is currently unobservable. As the point P2 moves to the point P3 as a result of expansion, light after this age cannot be observed. P2-P4 is a cosmic site currently observable, but actually exists in the actual universe of P2-P4 as a result of expansion. With the expansion, P2 changes its position to P3, so the currently visible galaxy P2 disappears from view. When that happens, the galaxy will leave our space-time. In other words, in the area near the Earth, there is no large vector difference between radial expansion and ring expansion, so the appearance does not change, but distant galaxies such as P2 and P4 disappear from view as the universe expands as it. Even if such a change occurs in the universe, it is thought that it cannot be confirmed on our time scale. Light reaching limit. The diffusion of light that began with the Big Bang has continued for about 13.8 billion years. In other words, the age of the universe is equal to the radius of the universe. We call the space-time range in which this wave universe can be observed space. This observable space-time range is different from the real universe, ring direction, because it is a past recorded image. Back in the past about 13.8 billion years, no contemporaneous universe expanding at the speed of light is visible. The thickness of the expanding sphere. If you look at this figure as a rotating body on the vertical axis, it will be an expanding spherical three-dimensional model. In this case, there are 13.8 billion light-years asterisk 3.14 spread in the direction along the spherical surface, xy, but large numbers cannot be assumed in the thickness direction of the spherical surface, z. This is the surface, two-dimensional, of the sphere where our universe expands. Is another coordinate axis still necessary? Or is it a thin space in the z direction, but do you see a fictitious thickness of 13.8 billion light-years in the direction of the past? Also, if the surface of the sphere is considered to be three-dimensional, it will be a four-dimensional model after a while, but it is difficult to understand as an image. Introduction of Space Map 2013 produced and distributed by MEXT during Science and Technology Week. This cosmic map depicts the universe based on the latest research, focusing on human beings. The flow of time from the human back to the birth of the universe is expressed in the vertical direction, and the spread of space of the universe is expressed in the horizontal direction. The whole trumpet-like shape shows that the universe has been expanding since it was born. The drop-shaped area in the center of the figure is the area of the universe that we can currently observe. Space-time structure, past spiral structure and future conical structure. If the length of the spiral curve is 13.8 billion light-years, the actual optical path is the hypotenuse of an isosceles triangle created by the real space distance and the time distance, so the real radius of the universe is 138/2 equals 9.7 billion light-years, and the expansion of matter the speed is 70% of the speed of light. The real radius is 9.7 billion light-years, so the great circle of the spherical universe is 2x 97x pi equals 61 billion light-years. The expansion of the space that began with the Big Bang has continued for about 13.8 billion years. We call the space-time range in which this wave universe can be observed space. Since the space-time range that can be observed is a past recorded image, it is different from the real space, ring direction. Back in the past about 13.8 billion years, the universe of the same era is not visible at all. The cosmic coordinates where our Earth is located are not different from the relative coordinates when the past universe was still small. So the observer's coordinates are expanding like the expansion of the universe, so their relative positions in the universe do not change. So we can observe the expanding universe in all directions. In addition, the future spacetime that can move at a speed of 20 to 30% of the light speed is the range indicated by the future spacetime cone. In this figure, it is a cone that represents the future after 10 billion years. If you can move at the speed of light, the apex of the cone will be 90 degrees. How far can you see the past of the universe? Cosmic microwave background radiation is microwaves that are observed almost isotropically from all directions on the celestial sphere. The spectrum is in good agreement with blackbody radiation at 2.725 K. An all-sky map of the CMB temperature anisotropy observed by the WMAP satellite. The temperature is higher in red than in blue, but the difference is about 1/100,000 of the average temperature. Even though it is a still image, the flow of time is recorded in it. Events cannot be confirmed without the thickness of time. The observed universe is visible at 13.8 billion years thick with light information coming along a continuous time plane. For example, imagine a record. A record is filled with a groove. Therefore, if you follow the groove, you can see everything. However, the number of grooves in the universe is infinite, so the spacetime is infinite. In other words, there are as many spacetimes as observers. The outer space we are observing, spacetime, exists in the continuous time plane from the Big Bang to the present, so the largest size is the age of the universe of 13.8 billion light-years. The light that we can observe is the multi-exposure image information that is magnified in the old age, and all ages are observed at the same viewing angle. There are countless worlds of the same principle even in high-dimensional space and multi-dimensional space. See the figure on the left. Observation points are written on the left, right, and upper sides of the cosmic map described so far. Both of these observation points exist in the real space 13.8 billion years after the Big Bang, but light from the same era cannot be confirmed mutually. And it is thought that a similar universe is observed from these observation points. There is a possibility that there is a planet similar to the Earth in this separate space-time, but there is no going or information coming. If you anticipate the arrival of an alien, it is highly likely that you are coming from this separate space-time, but in that case it is impossible unless you have space navigation that can move instantaneously. Space that does not require containers. How can you preserve the space without the need for a container? A system that moves freely in a gravitational field does not feel gravity. Perhaps the state, expansion, behaving freely in the energy field of the space is creating a universe that does not require a container. Our universe is a space that does not require this container, created by the Big Bang 13.8 billion years ago. Since space information as a container of the universe that existed before the Big Bang does not reach us, I think that its existence cannot be proved by observation. We call the area that can be observed the outer space, but it is thought that there is a real outer space that cannot be observed but is definitely present, and that there is a container of the universe surrounding it. What creates time? The system that carries light. I know that rotating motion creates gravity, but will the Big Bang also create a light-carrying system that is supposed to be symmetric to this gravity? The system that carries the light is thought to have its secret hidden in the structure of the universe. Our space is made up of oxygen and nitrogen atoms, but between these atoms there is a vacuum space. This vacuum space is continuous with the cosmic vacuum. Since outer space is expanding at the speed of light, photons without mass separated from matter are directly affected by the expansion of the space, so they appear to be diffused at the speed of light to observers. In addition, stars, galaxy disks, and chairs are connected to each other by gravity, so they are expanding in a lump with respect to the Big Bang coordinate system. It was thought that there was nothing, but this space is actually filled with the energy of vacuum, and photons are observed as the speed of light as a result of being dragged by the expansion of the space like particles suspended in a solution. Because the expanding state is considered to be a natural state according to the law of inertia, photons without mass are observed as light speed when viewed from us staying in space because they move in the same way as expansion of space. The beginning and end of the universe. What happened before the Big Bang? This is before our universe, so I don't think there is any evidence, but for the Big Bang to happen, there must be huge energy. Eventually, as the expansion progressed and the temperature of the universe decreased, the plasma began to have an atomic structure. Atomic structure creates resistance to the free expansion of space. As a result, spots of the portion where the expansion speed is fast and the portion where the expansion speed is slow occur, and this becomes distortion of the space, that is, gravity. The newborn material is accumulated by this gravity, and the universe that has been expanded and cooled after 13.8 billion years is the current figure. The temperature of the universe when it has an atomic structure is 6000 K. In the initial state of the universe, there was a large amount of star material in a narrow space. If the material distribution density of stars decreases with the expansion of space, many small stars such as the Sun have been created and they have become the current universe. After 13.8 billion years, the temperature of the outer space, which has been expanded and cooled, is 2.7 K. Looking at the temperature, the state of the universe has entered the final phase. The time required to cool from 6000 K to 2.7 K was 13.8 billion years. The place to be left will be absolute zero at 2.7 K. I think that the temperature drop will be hyperbolic, so it will take infinite time to reach absolute zero. So I think the current state of the universe will be stable. Observed cosmic events. Modern cosmology is the Einstein Cosmological Equation 1917, Big Bang Universe Model 1947, Inflation Universe Model 1981, Superstring theory and curtain cosmology are studied as high-dimensional cosmological models. These resulting illustrated cosmological models are what we see and hear. Galaxy collision shot by the Hubble Space Telescope. This image is also a great achievement of Hubble. Each scale is equivalent to a galaxy, though it is difficult to grasp the scale. The distance between stars in these galaxies is several light years apart. Such a sparse galaxy moves like a single object, and such a collision occurs. Hubble observed distant stars and discovered expansion, but the expansion of space and the expansion between galaxies are not the same thing. It is thought that the expansion of the space is simply expanding, but the distance between galaxies is far apart, and some are close and collide. It is said that the Andromeda Galaxy next to the Milky Way galaxy will collide with the Milky Way galaxy in the future. Because small movements of galaxies in the distance cannot be observed, galaxies have been observed to be moving away from us due to large movements, retreat speed, of the galaxies in the distance. The galaxy is moving in the expanding space, but the amount of individual movement is so small that it cannot be observed. By observation of WMAP satellite observing cosmic background radiation, we know that 70% of the material energy in the entire universe is dark energy, 25% is dark matter, and that hydrogen and helium, which seems to account for most of the matter we observe in dark matter, are only 5%. The light that can be observed by the WMAP satellite is an apparent cosmic image arriving at Earth along a continuous time plane. We want to know everything about the universe by observing 5% of glowing matter. Hubble Ultra Deep Field. The exploration area is about 1 degree of the constellation. It was performed from September 24, 2003 to January 16, 2004 using low-light astronomical cameras and infrared cameras. The resulting image shows more than 10,000 galaxies showing a redshift of Z equals 3 or more, about 11.7 billion light-years. Some of the galaxies show Z equals 6 to 7, from about 12.89 billion light-years. A galaxy of about 13.06 billion light-years was also shown. In addition, images of various strangely shaped galaxies were obtained, mixed with normal spiral galaxies and elliptical galaxies. This photograph was taken of the outer space from a starless part of the galaxy at an angle of view of about 1 degree. There is no direction of the origin of the Big Bang in the universe. This photo has an angle of view of about 1 degree, but in reality, a small universe in the early days of the Big Bang is enlarged and projected onto the whole celestial sphere. It is strange that the enlarged universe is projected at such a high density. It is thought that there are multiple optical paths connecting the early universe and the Earth in the meridian direction of the universe. As a result, it is thought that the same place is observed in various directions and various times. Otherwise, the initial universe, which is magnified and projected onto the celestial sphere, will not look so dense. Are the 3 coordinate axes converging to 1? The Big Bang universe looks like 3 coordinate axes converging on 1. Does this look like the 3-dimensional coordinate axes are extending toward the Big Bang? Therefore, the coordinate axis connecting the Big Bang to the coordinate origin is the 4th time axis. It is the Big Bang theory that thought that the coordinate system itself has expanded into the current universe since the Big Bang. This is a theoretical system that ignores the outside of the singularity because it is cosmology where existence has arisen from nothing. Space map drawn from Sloan Digital Sky Survey, SDSS. The Sloan Digital Sky Survey was launched in 2000. A project to observe more than 25% of the whole sky with a special optical telescope and accurately measure the position, brightness, and distance of galaxies and quasars included in that range to create a detailed cosmic map is there. This is a cross-sectional view plotting the distance and direction to the galaxy, from which the bubble structure of the universe was inferred. The distance from the observation point also means time. In the cosmic bubble structure, the arrangement of galaxies contains empty parts like bubbles. Space map drawn from observations of the 2DF Galaxy Redshift Survey. Anglo-Australian Observatory was conducted from 1997 to April 11, 2002 by a 3.9-meter telescope. This is a sky survey that measures the redshift of many galaxies. The survey revealed a large-scale structure of the universe for a portion of the nearby universe. This is the second largest redshift survey after the Sloan Digital Sky Survey, which was launched in 2000. Bubble structure of galaxy array. From images of Hubble Ultra Deep Field and images written by the Sloan Digital Sky Survey, the array of galaxies has a bubble-like feature. This is a structure in which galaxies do not appear to be uniformly scattered in the vacuum space, but appear to be stuck to the surface of bubbles. A meaningful galaxy array is drawn according to the unknown spatial principle. Big Bang model started from one point. When the expansion of outer space was confirmed, scientists went back to the time of space expansion and came to the idea that the Big Bang started from a single point. However, it is thought that the Big Bang universe started from the state that there is no substance of one atom size and no space, and the logic breaks down and it cannot be explained. A car's windshield starts at one point that triggers destruction, a point where pebbles hit the glass. The world where this glass cracking is progressing is the space-time of glass. Therefore, when observing the start of cracking from the space-time of glass, it is observed as if it started from one point. There are three models at the end of the Big Bang. Big Lips. Everything in the universe, from stars and galaxies to atoms and subatomic particles, will fall apart at some point in the future due to the acceleration of the universe. Theoretically, the measurement of the universe can become infinite in finite time. Big Chill, Big Freeze, means that as the expansion of the universe continues to accelerate, only photons fly and the temperature becomes extremely low, almost absolute zero. The Big Crunch is that if the mass, energy, contained in the whole universe is larger than a certain value, its own gravity will eventually change from expansion to contraction, and all matter and space-time in the universe converge to a dimensionless singularity thing. Since the Big Bang theory assumes that nothing has happened, nothing can be assumed before the Big Bang. Assembling the problem only from the observed facts will not allow you to escape from the observed facts. If you do not consider the vast nature of providence outside of our knowledge, you will be in the labyrinth of thought. Humans may like complexity, but history shows that when natural science issues were unraveled, it was so simple and beautiful that anyone could understand. From the celestial theory to the terrestrial theory in the solar system, to the era when the planet's orbit was considered to be circular motion, the complicated and esoteric theory became simple and beautiful by Kepler, who considered it to be elliptical motion. Light interference fringes. A path is created that separates once and then joins again. When a wave with the same phase is passed there, interference fringes occur. Thomas Young used this property of waves to show that light is a wave in an interference experiment using two slits. The implication of this experiment is that even a quantum of a unit quantity shows a wave property. The double-slit experiment was the first in the world to demonstrate that waves do not require multiple particles in order to exhibit their properties. The open question is that light has both the properties of particles and the properties of waves. This is consistent with having two properties, assuming that photons are carried by expansion waves in space. It is also the same phenomenon that other elementary particles can fly through space at the speed of light, so there is no contradiction. Since the expansion of the space is the speed of light and time, the speed of light is constant in each field. Observed values at the quantum level are the positions and energies of the quanta when the space-time wave stops, so the quanta are observed as points. On the other hand, the state where quantum exists in spacetime is a state that has a temporal activity width. This is why observations seen as waves and observations seen as particles coexist. In the elementary particle space, the size of the observed event cannot be determined with the accuracy of the ruler of time, so it is thought that a mysterious observation situation has been created. In the observation result when time is stopped, it is observed as a particle and as a wave with a time width indicating the property of the quantum level. Newton's law of motion. Newtonian mechanics regards a mass point as a mass point in which the total mass is concentrated at the center of gravity and has no size, and puts the properties of the mass point in terms of motion into law and proposed the following three laws of motion. In addition, these laws are the basic idea even for mass points that cannot be regarded as mass points, continuous bodies such as rigid bodies, elastic bodies, and fluids. First law, law of inertia. Unless a force acts, a mass moves in a static or constant velocity linear motion. The motion law is described using a coordinate system that satisfies this. Second law, Newton's equation of motion. The mass acceleration A is then proportional to the force F acting on the mass and inversely proportional to the mass m of the mass. F equals ma. Third law, law of action/reaction. When a force acts between two mass points 1 and 2, a force F21 acting on mass point 2 to mass point F2 and a force F12 acting on mass point 1 to mass point 2 are equal in magnitude and opposite to each other. Many laws and theorems in the field of mechanics are basically derived from the above three laws. The motion equation, which is a second-order ordinary differential equation with respect to time of the position vector, is an equation that determines the motion state at any time given the position and momentum, or velocity, at a certain time. Assuming the law of conservation of energy holds. Literally interpreting Einstein's E equals mc superscript 2, the energy is the product of the mass of the material and the square of the expansion rate. However, the speed of light c is considered to be the same as the expansion speed. Of these three elements, the ones that can change are c and m. Therefore, when the amount of substance decreases, the expansion rate increases, or when the amount of substance increases, the expansion rate decreases. In the past universe, galaxies seem to be densely distributed in a small space. As the universe expanded, the distribution density of matter decreased and the expansion rate increased. This is considered to indicate the accelerated expansion of the universe. Considering a supernova explosion as a situation where matter is converted to energy is the phenomenon where a black hole swallows matter and kinetic energy, a scene where energy is transformed into matter. What is a black hole in general relativity? It is defined as a region that cannot have a causal relationship with other regions of spacetime in the future. The size of the black hole is reduced by the increase in the density of the black hole falling off from the expansion system of the space, so the gravitational sphere is considered to be extremely small. The reason why the huge black hole, which is said to be at the center of the galaxy, is stable without swallowing it is because the gravitational sphere is extremely small. In this way, the only thing the black hole swallows is to think of anything other than going straight to the black hole. I think it is more appropriate to think that a black hole is not a gravitational field that cannot escape even light, but has deviated from the observable spacetime due to a large time drop. I wrote that it is a temporal drop, but what actually happens in and around the black hole is that the expansion speed, light speed, is extremely slow. Therefore, the time drop and the extremely slow expansion rate have the same meaning. In other words, the expansion of the space in the black hole is considered to be discontinuous. Expansion speed, light speed, equals operating speed over time, c/t equals 1. This shows the principle of light speed invariance. The actual expansion speed, light speed, differs between the inside of a substance and the vacuum space, but all measurements of expansion speed, light speed, in all fields have the same result. Assuming that the speed of light is a photon carried to the expansion of space, when the expansion of space disappears, light cannot exist. Since black holes are compressed at a very high density, they may not have space inside. In that case, the continuity of the space is lost, so no observations can be made. Einstein's idea. Einstein's famous formula E equals mc superscript 2 says that the product of the square of matter and the speed of light is energy, but what happens in the universe is the opposite. In other words, energy has turned into a substance and the speed of light, expansion rate. And now it is thought that the expansion of the universe is accelerating due to the fact that matter is converted into energy like stellar nuclear energy or supernova explosion. According to special relativity, the speed of light is constant for any inertial system. According to general relativity, gravity and acceleration are equivalent, and gravity distorts space and time. Gravity distorts time as well as space. Is this because gravity is considered higher than time? If the time is not constant, neither the speed of light nor the gravity, expansion acceleration, will be determined. Is there a mechanism that creates time in an area we do not yet know? Or is time simply a concept created to recognize changes in things? About the time Einstein guessed. Time goes slowly in a strong gravitational field. The expansion rate of the space is considered to be slow near the strong gravitational field, that is, near the black hole. This equates to the slower operating speed of time, so time progresses slowly. Time advances slowly in an accelerated rocket. In an accelerated rocket, the expansion speed of the space becomes relatively slow, so the time advances slowly compared to the clock on the ground. By writing so far, I finally understood the incomprehensibility of Einstein's time. If there is no expansion of the space, the atomic oscillation does not occur and the atomic clock stops. Also, photons riding on the wave of expansion have zero time. Einstein Equation. A field equation describing universal gravitational fields that Einstein derived in general relativity in 1916. This is an extension of Newton's law of universal gravitation that can be applied to strong gravitational fields. become. It is also called Einstein's gravitational field equation. The difficult Einstein equation is still incomprehensible, but I felt that it was very compatible in writing cosmology. Time is force. I think that it is the same if we consider the speed of light as the speed of expansion of space. In Einstein's era, we did not think that the universe was expanding, so we could not think of the cause of light speed or gravity. According to general relativity, a massive object distorts the surrounding space-time. In other words, gravity is described as a space-time distortion. The theoretical result is the Einstein equation, which is expressed as follows. The left side is a geometric quantity indicating how the space-time is bent, curvature of the space-time, and the right side is an amount indicating the distribution of the material field. Roughly speaking, if you substitute a star-like substance or energy into the right-hand side, you can read how the space-time around that substance bends. If the distortion of the space is determined, the equation of motion of the material moving in the space is determined, so the material distribution will also fluctuate. G mu nu equals r mu nu 1/2 r g mu nu on the left side is called Einstein tensor. Lambda is the cosmological constant, and this term is called the cosmological term. R mu nu is the rich tensor, r is the scalar curvature, and both are geometric quantities written by differentiation of the spacetime metric tensor g mu nu. In other words, the Einstein equation is in the form of a system of partial differential equations for metrics. T mu nu on the right side is the energy-momentum tensor. The coefficient kappa is called Einstein's gravitational constant and is related to Newton's gravitational constant g by kappa equals 8 pi/c4g, pi is the pi, c is the speed of light. Since both sides of the Einstein equation are four-dimensional second-order symmetric tensors, decomposition of each component gives 10 independent equations. 4 of them correspond to the law of conservation of energy and the law of conservation of momentum, and the remaining 6 equations related to the space component of g mu nu correspond to the spacetime equation of motion. These are the 6 partial differential equations of the second order of the time derivative, but there are 4 degrees of freedom in selecting the coordinates. If there are 4 constraints to perform time evolution while satisfying the conservation law, even in a vacuum, even the first-order differential equation has 4 degrees of freedom. This degree of freedom means that there are 2 modes of gravitational waves that transmit spacetime distortion as waves. A tensor is a generalization of a linear quantity or a linear geometric concept, which can be expressed as a multidimensional array by choosing a basis. However, the tensor itself is an object determined without depending on a specific coordinate system. The number of sets of array indices needed to describe the corresponding quantity for each tensor is called the rank of that tensor. If you read this Wikipedia text when you started writing cosmology, time is force, you wouldn't understand it. This equation indicates that the expansion acceleration that distorts the space equals energy. This formula contains G and C, but this is simply a relation to Newton. I thought that the reason why the space could be distorted was that the unevenness of the material density in the space became the unevenness, acceleration, of the expansion speed of the space, causing gravity. An element that is not a linear change called the accelerated expansion of the universe has entered, so I think it is ambiguous whether the structure of outer space is a property that can be expressed by equations. Rather, God doesn't roll the dice, which could be the probability of interaction that Einstein hated. The Planck unit system. The Planck system is a natural system of units proposed by Max Planck. Planck's unit system is defined with the following constant as 1. Simplification of physics equations. Planck's unit system is defined as light speed in vacuum, universal gravitational constant, Dirac constant, Coulomb force constant, and Boltzmann constant as 1. This is equivalent to thinking of the expansion energy of space as the only energy. In addition, the large number hypothesis proposed by Dirac in 1937 has a value of 10 to the power of 40, or its square, in the dimensionless number obtained from some basic physical constants as follows. Proton-electron electromagnetic force-gravity ratio. The ratio of space-age to the time that light travels the radius of the proton. Number of protons and neutrons present in space. Dirac, on the other hand, thought that these were not incidental but constant. If this Dirac hypothesis is correct, it means that the physical constants have changed over time since the birth of the universe. This is because the swinging energy of the space is the only energy. The universe from the early universe to the present is in its current form with all physical constants changing. Therefore, it is necessary to integrate the expansion unit system. This is something I noticed in June 2019, but I will write it here. Law of Entropy Increase. The second law of thermodynamics is an increase in entropy with the rule of thumb that everyone says that heat flows from hot to cold one and vice versa. By writing mathematical expressions delta Q/T is called entropy. Here delta Q is the temperature change, T is the temperature. Therefore, if the heat transfer of the above two objects is written by the equation, the higher temperature is taken as Th, and the lower temperature is taken as TL, delta Q/TL, delta Q/TH0. This is entropy change. Since delta Q is the same as TH/TL in the first and second terms, it is always positive. Entropy will surely increase because the amount of heat moved from hot to cold one by only delta Q. The enthalpy increase is the more versatile word that heat flows from high to low to more versatile terms. Big Bang is also an entropy increase because high energy density clusters will diffuse into low energy density. Since the energy amount of the entire universe does not change, let T14 be the time of the Big Bang and T14 be the present after 13.8 billion years delta Q/T14, delta Q/T00. It seems to be like this in entropy, but it seems to indicate that the small solidified energy diffuses and becomes scarce if it says more clearly. Law of increasing entropy is the law of cosmic expansion. Derived from thermodynamics, the fact that the potential of the universe itself, thermodynamic gravitational substance, diffuses is called entropy increase, so it is difficult to understand as a word but it is easy to understand, in other words, a decrease in potential. What is Brownian movement? The yellow fine particles move irregularly due to the collision of the black medium particles. It is a phenomenon in which fine particles floating in a solvent such as a liquid move irregularly. In 1827 Robert Brown discovered the suspended particles floating in the water from the pollen bursted with the osmotic pressure of water during observation under a microscope. Although the cause remained unknown for a long time, the paper that Einstein was caused by the irregular collision of the molecules of the medium which was thermodynamically released was published, and the existence of atoms and molecules which were uncertain at the time was confirmed. It was shown the possibility of proof. Later it was verified experimentally and confirmed that atoms and molecules certainly existed. This phenomenon Brownian motion is used in a fairly broad sense, and similar phenomena are described as thermal noise in electric circuits and irregular vibrations of microscopic mirrors placed in dilute gas as a category of Brownian motion. Einstein's explanation is not described for the energy creating the irregular motion of the molecule. I think this energy is the expansion energy of the space that exists in the whole universe. About dark matter/dark energy. Dark matter is a hypothetical substance that is not optically observable with no electromagnetic interaction and color electrification among interstellar matter in space and is called dark matter. The indirect discovery of dark matter was pointed out in the 1970s from observation of the rotation speed of the galaxy by Vera Rubin. As a result, about 10 times as many substances as optically observable substances existed. The mismatch between the luminance distribution and the dynamic mass distribution of this galaxy is called the rotation curve problem of the galaxy. Through this problem the existence became clear. The fact that the rotation angular velocity of the galaxy is the same for both the inside and outside edges is the rotation curve problem of the galaxy. This is not only a galaxy being a collection of individual stars but also a group. It is thought that the distortion of individual space is synthesized, and this makes the distortion field of space as a whole. Distortion, gravity, of the space is observed in the interior and the periphery of the galaxy by the observation using the gravity lens effect. If gravitational force is created from the expansion acceleration of the space, the gravitational field will change over the death and birth of the star. Therefore, since the energy of the space is not constant, it is considered that the gravity field is not uniform. Current thinking of gravity thinks that gravity will occur if substances are present. I cannot say that the expansion speed of the space is uniform, so I think that the difference of this expansion speed becomes the distortion of space and is observed as gravity. Even if there are no substances, if there is a spike in the expansion rate, it becomes distortion of the space and becomes gravity. If this is the cause, I cannot find it even if I look for dark matters. It is reasonable to think that there is a substance, dark matter, drifting in the space without becoming a star, but many researchers are supposing other special particles. In any case, it seems that there are only about 5% of hydrogen and helium which seems to occupy the majority of the substances we are observing. Since the movement of the galaxy and the expansion of the space are not the same, it is not that the expansion of the space is accelerating even if it is said that an accelerated expansion of the galaxy is observed. The placement of the galaxy is a state that is constantly left behind without expanding the space expansion. I believe that this marginal state is an energy source that creates light velocity gravitational mass time. There is no way to explain this, although initial inflation is not continuing, but there is more energy that expands the space in an accelerating manner. I think that dark energy is the basic energy expanding the universe. In other words, we believe that the diffusion of light uniformly occurring in all directions shows the function of dark energy. The structure of the Milky Way galaxy. The Milky Way galaxy with our Earth is also a cluster of objects such as a number of stars and star gases, and the total mass is estimated to be 1.26 trillion times of the Sun. Among them, the total of the masses emitting electromagnetic waves such as visible light is 5% and the majority of mass is considered to be dark matter. We cannot see 95% of the cause of mass. I think that the appearance of the universe we are seeing will be quite different from the actual situation. In the vicinity of the center of the Milky Way galaxy there is a high-density bulge consisting of relatively old stars, and there are young stars and disks with a diameter of about 100,000 light-years consisting of interstellar matter surrounding it. The thickness of the disk is about 150,000 light-years around the center and has a convex lens shape of about 1,000 light-years at the periphery. There are spiral arms in the disk where many bright star and diffused star nebula are seen. On the outer side of the bulge and the disk there are spherical halos about 150,000 light-years in diameter, consisting of about 130 spherical clusters. In addition, the center of the galaxy is located about 26,000 light-years away from the Earth and in the direction of the seat. It is thought that there is a mass black hole in the center of this galaxy. The galaxy repeats collisions and grows to a large size, but it is thought that bidirectional vectors in collisions are combined and become a rolling body that spreads like a plane. If three-way galaxies collide at the same time, it may become a galaxy with a three-dimensional structure, but since there are few cases in this case, many galaxies are rotating and spiral. The shape of the galaxy is thought to be like taking a picture of the changing state in eternal time. The oldest celestial bodies in the Milky Way galaxy are said to have been born 13.2 billion years ago. This seems that the size of the Milky Way galaxy does not change as much as the expansion of the space. We think that the visible disk shape is a galaxy, but a spherical halo about 150,000 light-years in diameter is the whole shape of the Milky Way galaxy. And rotation of halo is observed as galaxy rotation. So far, I've written an overview of my conventional Big Bang cosmology and my interpretation. I searched for the big picture of the universe while modeling the Big Bang cosmology that started from one point. But I think the Big Bang cosmology contains the contradiction that nothing has come from nothing.